This is what Japan's next-generation stealth fighter will look like. It's a joint project with the UK and Italy.
Japan has officially joined the race to develop a sixth-generation fighter jet, incorporating advanced stealth technologies, laser guidance, and super weapons. While Japan has long been known for its technological achievements, such as microcomputers, CDS, 3D printing, and karaoke, it has historically lagged behind world superpowers in the military sphere due to its pacifist constitution. After World War II, under pressure from the United States, Japan adopted a constitution in 1947 that prohibited offensive warfare and the possession of armed forces. As a result, for 75 years, Japan has not had a formal army, and instead, its military force is referred to as the Self-Defense Forces, SDF, comprising 250,000 personnel. Despite this, Japan now ranks fifth in the Global Military Power Index, with its defense budget reaching a record $53.8 billion last year. The United States is supporting Japan's military expansion in response to the growing influence of China and Russia in the Pacific, positioning Tokyo as a key player in the US-led anti-China coalition. This cooperation dates back to 1952 when Japan and the US signed an administrative agreement that allowed American forces to be stationed on Japanese territory, formalizing their military alliance. Historically, Japan has relied on American weaponry but has also pursued independent military development, particularly in aviation. In 2008, Japan launched a program to develop a fifth-generation fighter jet after being denied the purchase of US F-22s due to export restrictions. Consequently, Japan developed its first stealth fighter, the Mitsubishi X-2 Shinshin, as a testbed for new aviation technologies. With more than 220 companies involved and 90% of the components produced domestically, the X-2 represented Japan's commitment to self-reliance in defense technology. Weighing 9 tons, measuring nearly 50 feet in length, and accommodating one pilot, the X-2 was developed at a cost of $400 million, considered modest for a fifth-generation fighter but significant for a prototype. It features advanced fly-by-wire control systems using fiber optics, which enhance data transmission speed and resilience against electromagnetic attacks. Additionally, its self-healing control system detects damage to control surfaces and adjusts handling automatically. Despite initial expectations for mass production, the X-2 was only intended for experimental purposes, lacking onboard weaponry. Japan's ability to develop such technology was partly influenced by engineering insights gained from both the United States and the former Soviet Union. Notably, in 1976, Soviet pilot Viktor Belenko defected to Japan with a MiG-25 fighter jet, landing on the Japanese island of Hokkaido and later seeking asylum in the US. The MiG-25, recognized as the world's fastest combat aircraft, capable of flying nearly 3 times the speed of sound, was extensively studied by both Japan and the United States before being returned to the Soviet Union in disassembled form. Developed in response to American high-speed aircraft designs, the MiG-25 was equipped with 4 air-to-air missiles, 2 with thermal homing heads and 2 with radar homing heads, allowing it to engage targets over long distances. It was also designed to withstand extreme conditions, as speeds above Mach 2.5 caused conventional aluminum structures to lose their strength due to overheating. To counter this, the aircraft was constructed primarily from stainless steel and titanium alloys. The MiG-25 set 29 world records, including an absolute altitude record, underscoring its engineering prowess. Japan and the United States had already mastered Soviet technologies and incorporated them into future developments. Another key technological advancement for Japan was the F-35. In 2020, the two nations signed an agreement for the supply of 105 fifth-generation F-35 fighter jets, including engines, electronic warfare systems, communications, and related services, with a total deal estimated at $23 billion. This agreement elevated Japan's Air Force to the second position globally, after the United States, in terms of the number of fifth-generation aircraft, totaling 147 units. The distribution of F-35 types within Japan's self-defense forces is also notable, consisting of 63 F-35A land-based aircraft and 42 F-35B vertical landing fighters. The F-35 is recognized as the most versatile fighter jet ever built. Its development began in 2001 when the F-35 prototype won the Joint Strike Fighter competition aimed at replacing various aircraft, including the F-16, the A-10 for low-altitude support, and the Harrier jet for vertical takeoff. Designed for multiple combat roles within the U.S. military, the F-35 is capable of carrying out bombing missions, supporting ground troops, and engaging in air combat, boasting substantial weaponry and payload capacity. Theoretically, its versatility should redefine modern warfare, though some analysts remain skeptical of this concept. Nevertheless, its technical features are impressive, particularly its advanced helmet system, which allows pilots to see through the aircraft. Visibility has traditionally been a challenge in fighter jets, with older models relying on multiple screens displaying real-time images from 4 different angles. However, the F-35's helmet, priced at $400,000, integrates real-time infrared camera feeds into a seamless augmented reality display, enabling pilots to effectively see through the aircraft itself. The F-35's stealth capabilities allow it to bypass enemy air defenses easily, and its internal weapons bay ensures minimal radar detection. Building upon these advancements, Japan has chosen to take a step forward rather than merely catch up. The country is set to unveil a prototype of its 6th-generation stealth fighter, the Mitsubishi FX, this year. Concept images of the FX reveal a rounded fuselage design akin to the F-22, with twin-engine exhaust configurations. Mass production is scheduled for 2031, and the aircraft will ultimately replace the Mitsubishi F-2 currently in service. The Mitsubishi FX may bear similarities to the F-22, as it was conceptualized in the late 1990s when the US decided against exporting the F-22. However, the US has officially stated that it does not intend to share the advanced technologies necessary for Japan's 6th-generation fighter development. Consequently, Japan has turned to the UK and Italy for collaboration on what is expected to be one of the most powerful fighter jets ever built. Japan's intention to develop a 5th-generation fighter jet under the FX program became public knowledge in late 2020. The project originally aimed to create a combat aircraft to succeed the Mitsubishi F-2, with initial designs resembling a hybrid of the American F-35 and F-22. However, the Japanese government later decided to advance directly to a 6th-generation fighter by merging the British Tempest program with the Japanese FX project. The result is expected to be the most advanced fighter jet in history, informally dubbed Godzilla. This aircraft is projected to be extraordinarily fast, highly maneuverable, equipped with laser weapons and an advanced stealth system, capable of controlling drones remotely, and executing attacks autonomously without human intervention. Beyond weaponry, its most crucial component will be its engine, and Mitsubishi, with its expertise in aerospace engineering, is at the forefront of developing this technology. Despite the complexity of hypersonic engine technology, Japan is committed to pushing the boundaries of innovation in aviation. The development of the Godzilla fighter jet requires addressing numerous technical challenges, particularly in cooling components exposed to extremely high temperatures. The aircraft's engine is designed to handle these challenges effectively, featuring additional air guides that allow more air to enter the combustion chamber, where it mixes with fuel to generate jet thrust. This advanced technology enables the fighter to reach speeds of 1,990 miles per hour in its basic flight mode. However, it also features an advanced mode, which incorporates a hydrogen tank for short-term flight, boosting its speed up to 2,500 miles per hour. Even the American Dark Star may struggle to compete with this level of innovation. Additionally, the aircraft is designed with vertical takeoff and landing capabilities, further enhancing its operational flexibility. Another critical component of the 6th-generation fighter is its cutting-edge weaponry. The British Laser Directed Energy Programme, LW, has been conducting extensive tests to refine the accuracy and power of next-generation laser weapons. They have successfully developed a system capable of both offensive and defensive operations, making it ideal for fighter jets. The laser weapon system has a power output of 300 kilowatts and utilizes infrared radiation to target enemy aircraft and equipment. Upon absorption, the heat generated can reach up to 1,000 degrees Fahrenheit, which can cause enemy tanks, artillery, and aircraft munitions to detonate internally, effectively destroying them. Given the rapidly evolving threat landscape, laser-directed energy weapons are becoming increasingly essential. Equipped with such powerful weaponry and unmatched speed, the Godzilla fighter can infiltrate enemy bases and eliminate critical targets with ease. While adversaries may attempt to shoot it down, doing so would be extremely difficult, as the aircraft operates at an altitude of over 72,200 feet, well beyond the reach of most modern air defense systems. Furthermore, the Godzilla fighter features multiple levels of radar protection. Firstly, instead of merely using a special reflective coating like older stealth aircraft, it employs an advanced composite material that is both lightweight and highly durable while remaining undetectable by radar. Secondly, the aircraft is equipped with a radar blocking system that emits precisely calibrated waves, preventing enemy radars from identifying the aircraft in the air. These innovations represent a vision of future warfare, offering a glimpse into the possibilities of next-generation aerial combat. However, one major concern remains: the risk of cyber attacks. Enemy hackers could potentially attempt to infiltrate the system and take control of the aircraft remotely. Despite this, representatives from BAE Systems have assured that Godzilla will be equipped with advanced cybersecurity measures, featuring an automatic coding system for critical security functions. This ensures that the aircraft is resistant to remote hacking attempts and immune to interference from jamming devices. The collaboration between European nations and Japan is already producing remarkable results in aerospace and defense technology. Yet, a key question arises: why did the United States choose not to participate in this ambitious program? The U.S. Secretary of Defense, Lloyd Austin, has publicly expressed his approval of Japan's advancements, but the reasons behind America's decision to refrain from direct involvement remain a topic of speculation. The cooperation between London and Tokyo has taken an interesting turn, with discussions about jointly developing unmanned aerial vehicles that will operate alongside next-generation fighters. However, this situation raises questions. Could it be that the United States and Japan are only creating the illusion of a break in their relations while secretly strengthening their collaboration? The reality suggests just that. Britain and Italy have been reluctant to share their advanced technologies with the United States, as global politics remains highly complex. The US had previously attempted to acquire certain European technologies but was denied access. This is where Japan played a crucial role, obtaining all necessary data and likely passing it on to the Pentagon. It is highly probable that the United States and Japan are covertly working on a new fighter jet or enhancing their previous joint projects, such as the F-35A divided by B fighters, which are already in active service in both countries. The Japanese F-35A is primarily designed for strike missions, featuring a maximum takeoff weight of 63,900 pounds. A combat radius of 670 miles, and the ability to reach speeds exceeding 1,180 miles per hour. By the end of 2020, the Japanese Air Force had received 8 F-35A aircraft, with approximately 100 more scheduled for delivery by 2025. However, these will not be the standard F-35s known today. Lockheed Martin has introduced a major modernization of the aircraft, elevating its power and capabilities to a completely new level. The upgraded F-35 is designed for high-intensity attacks, carrying more than a dozen Japanese supersonic maneuverable missiles with a total weight of 6,600 pounds. These missiles travel at speeds 3 times faster than the speed of sound and are capable of destroying enemy targets purely through kinetic energy, even without an explosive warhead. Future weapons are expected to be vastly different from those in use today, leading to innovations such as flexible payload bays that accommodate various types of missiles and bombs. Additionally, the fighter is equipped with 6-cluster munitions or a nuclear bomb, the sheer power of which is beyond description. The aircraft also carries kamikaze drones for offensive operations, as well as reconnaissance drones that gather intelligence on enemy positions and relay real-time data directly to the pilot's helmet. A defining feature of the upgraded F-35 is its adaptability, designed with systems that can be upgraded as seamlessly as downloading an app onto a smartphone. This ensures that the Japanese F-35 remains highly relevant and can swiftly adapt to mission-specific requirements. The pilot can download necessary configurations and enter battle on autopilot, fully confident that the aircraft is optimized for even the most demanding conditions. Furthermore, Mitsubishi's advanced engine technology has been integrated into the aircraft, significantly enhancing its speed. The fighter is now capable of executing complex aerial missions at a speed of 1,925 miles per hour, with the potential for further increases. Naturally, stealth remains a crucial aspect of the aircraft's design. With advancements in technology, engineers developed a specialized material that either reflects radar waves away from the source or alters the trajectory of incoming signals. As a result, enemy radars are unable to detect the aircraft since the waves never return to the receiver. Additionally, Japanese engineers have installed the cutting-edge AN/APG-81 radar, which enhances the aircraft's effectiveness against both air and ground targets. This radar is particularly useful for engaging adversaries in low-visibility conditions, whether due to weather, smoke, or other environmental factors. Even if the F-35 were to run out of ammunition, it would still serve as a highly valuable reconnaissance aircraft, transmitting critical intelligence to other F-35s through a secure internal communication network. As previously stated, this next-generation F-35, jointly developed by the United States and Japan, is set to function as an invisible flying command center, a true stronghold in the event of full-scale warfare. The sheer sophistication of its technology places it in the category of sixth-generation fighter jets, reaffirming the significance of US-Japanese cooperation in the realm of modern military advancements.